All right, you guys, in this section, we're going to be talking about composite functions. All right, so by definition, a composite function giving two functions f and g, the composite function denoted by f composed of g is defined as f composed of g of x equals f of g. Okay, the domain of f composed of g is a set of all numbers x in the domain of g, such that g of x is in the domain of f. Okay, so before, anytime that we've had a function, okay, we've always placed a value in it. So for example, if I gave you f of x equals x plus 5, and I told you to give me f of 2, you placed that 2 everywhere there was an x in this function. So that would have been 2 plus 5, which gave you 7, okay? The difference now when we begin to talk about composite functions is that you're not going to just be putting a value into a function, you're going to be putting functions inside of functions, okay? So if we were to have this same example, f of x equals x plus 5, but now we also have g of x equals x plus 2, and I wanted you guys to give me f of g of x. That means now instead of putting a value everywhere that you see x in the f function, you're going to put the entire g function. So the way that that would look would be x plus 2 plus 5, and then you would simplify, okay? So if that's a little confusing now, it's okay. We're going to do some more examples, but that's going to be the major difference, okay? The other thing that's going to be a little different is when you're finding the domain, okay? So remember, when we're looking for a domain, we're looking for the x values or the input values that we can put into a function. So because now we're going to have functions inside of functions, when you look for the domain, you have to look for the values that clear the first function as well as the values that clear the second function, okay? And we're going to do examples of that as well. All right, so let's move on to our first set of examples. So it says evaluating a composite function. So they say, suppose that f of x equals 2x squared minus 3 and g of x equals 4x. Find the following, okay? So A is telling us to do f composed of g of 1. Okay, now that's our standard notation for our composite functions. Me personally, I like the long-handed version, which would be f of g of 1 of x. Okay, so I personally like the second notation because I like to see who's actually the inside function. Like, what's the function that's going to be inside of the other? But both notations are perfectly correct. So if you like the left-hand side, you can use that. If you like the right-hand side like me, you can use that as well. They mean the same thing. They're equivalent. All right. So when you're doing these problems, I don't know if you guys have ever seen those dolls that stack inside of each other. So you have the little one that goes inside the bigger one, that goes inside the bigger one. All right. When you're doing these problems, you're going to think about them like those dolls. So you're going to work from the inside out. So the first thing I'm going to do when I'm evaluating this function, I'm going to compute what g of 1 is. Whatever that value is, then I'm going to plug it into f and then compute that one. Okay. So you're always working from the inside out. So let's erase this. All right, so we're going to do the g of 1 first because that's the inside. All right, so we want to do g of 1. So that means everywhere in our g function where we see an x, we're going to plug in 1 in its place. So that's going to be 4 times 1, and 4 times 1 is 4. So that means the inner part of this function is now equal to 4. So now what I'm looking for is f of 4. Okay, let's do that. Let's do it in a different color. All right, so now I'm going to do f of 4. So that means everywhere in the f function where there's an x, I'm going to plug in 4. So I have 2 times 4 squared minus 3. All right, 4 squared is 16. 2 times 16, that's 32. Minus 3, that's 29. Okay, so my answer for that problem would be 29. Okay, cool. Let's try B. All right, let's change back our colors. All right, B says do G composed of F of 1. Okay, so notice for this one, so sometimes I call these functions, so when I see f composed of g, sometimes I call that fog. And then sometimes when I see g composed of f, I call that goth. Okay, so notice that with these, the order of our functions has changed. In example A, we had f composed of g, so g was the inside function. Now we're doing g composed of f, so f is the inside. Okay. One thing I also want you guys to take note of, okay, when you see this notation for our composite functions, whether it be f composed of g or g composed of f, notice that this symbol means composition, okay? It looks like a degree symbol. It is not fully enclosed like multiplication, okay? So just be careful of that as you move through this section, that we're not multiplying these together, we're composing them, okay? All right, so once again, I'm going to write this problem the long-handed way. G composed of f of 1, okay? And I'm going to think about my dolls again, which means that I'm going to work from the inside out of this problem. So I'm going to find out what f of 1 is first. So I'm going to go f of 1, okay? We're using these same f and g functions, okay? So f of x is 2x squared minus 3. So that tells me I'm going to do 2 times 1 squared minus 3. 1 squared is 1. 2 times 1 is 2 minus 3, which is negative 1. So that means the inside function is negative 1. Now I need to compute what g of negative 1 is. Okay, let's change our color. All right, so g of negative 1 means everywhere in the g function where I see an x, I'm going to put a negative 1 in its place. So I have 4 times negative 1, which gives me negative 4. So my answer is negative 4. Okay. All right, let's move on to C. All right, let's move down a little bit. All right, so for C, we're doing f composed of f of negative 2. Okay, I'm going to write it the longhand way again, f composed of f of negative 2. Okay, so notice this time we're putting f inside of itself. We're composing the same function within itself. All right, so I'm still going to do what I did before. I'm going to work from the inside out. So the first thing I'm going to do is find f of negative 2. All right, so that means everywhere in the f function where I see an x, I'm going to plug in negative 2. So it's going to be 2 times negative 2 squared minus 3. I'm going to simplify that. Negative 2 squared is 4 minus 3. 8 minus 3, that's 5. So this inner part is 5. So now I'm going to do f of 5, which means everywhere in the f function where I see an x, I'm going to plug in 5. So that's going to give me f of 5 equals 2 times 5 squared minus 3. 5 squared is 25 minus 3. That is 50 minus 3, which is 47. So my answer for that one is 47. All right, and then let's try the last one. So if you guys want to try it by yourself, you can pause the video here and try it and then see if you get the same answer as me. All right, so let's see, we have D. So D wants us to compose G inside of itself. Okay, so I'm going to write it the longhand way. G of negative 1. So once again, I'm going to work from the inside out. So I'm going to do g of negative 1 first. And our g function was 4 times x. So I'm going to do 4 times negative 1, which is negative 4. So now I need to do g of negative 4. All right, change our color. So we're going to do g of negative 4. Which is 4 times negative 4, which is negative 16. So those are our answers. All right, so we've done A, B, C, and D. So hopefully now you guys know how to evaluate a composite function. Cool.